Okay, so 25-2 should be the second video you're watching for the day. We're going to do two things. We're going to solve square root functions, and then we're going to identify extraneous solutions. All right, this will kind of happen as this is happening, but the main thing here is we're going to solve square root functions. All right, we need to write this fact down. All right, so this fact says the square root of x is the same thing as x to the power of 1/2. All right, when we're square root, it's the opposite. So we have x squared. So how do you undo square root? We square it. Well, that's the same thing as x to the 1/2 squared. Well, a power to a power, you multiply. So that equals x to the 1/2 times 2. Well, what's 1/2 times 2? It's 1. So that equals x to the first. All right, so the square root and the squared undo each other. So 1/2 and squared would undo each other. Square root of x is the same thing as x to the 1/2. All right. If you don't understand why, you just need to know that this and this are equivalent. All right. So we're going to solve, and we're going to say the square root of x minus 3 plus 4 is equal to 9. All right. So our first step is always to get the radical by itself. All right, just like if the x, get it by itself, but these are grouped together for now, so get the radical by itself. So we're going to minus 4. So we have the square root of x minus 3 is equal to 9 minus 4, which is 5. All right, once you've got the radical by itself, so I'm going to write isolate radical. That means the same thing as get the radical by itself. Isolate the radical. All right, once you've done that, you want to get rid of the square root by squaring. Get rid of radical by squaring. So that becomes squared, and that becomes squared. So the square root of x minus 3 squared is just x minus 3, and then 5 squared is 25. And then solve for x. So plus 3, x is equal to 28. All right, once we get this, we want to check the solution. All right, because you can already tell we're going to have extraneous solutions. All right, so solutions that mathematically work out but then don't actually work when we plug them in. So the square root of 28 minus 3 plus 4 is equal to 9. Well, 28 minus 3 is the square root of 25 plus 4 equals 9. And so square root of 25 we could say is 5. We're going to ignore negative 5. We're going to say positive 5 plus 4 is 9. 5 plus 4 is equal to 9. And that is true. So it works. Generally, I circled it prematurely. Normally I would get my solution, check it, and then once I've checked it, that's when I normally go back and circle it and say, yes, the solution works. All right. Let's try another one here. X is equal to x plus 1 to the 1/2 plus 5. All right, so the first step is to isolate the radical, which is here. This is the square root of x plus 1. So we're going to minus 5, minus 5. X minus 5 is equal to x plus 1 to the 1/2. All right, after we isolate the radical, we're going to get rid of the radical by squaring. So both of these pieces are going to get squared. And so x plus 1 to the 1/2 squared is just going to give us x plus 1. And then x minus 5 squared, I do x minus 5 times x minus 5. And so x times x is x squared. X times negative 5 is negative 5x. Negative 5 times x is another negative 5x. Negative 5 times negative 5, positive 25. So we get x squared minus 10x plus 25 is equal to x plus 1. All right, and so the next step was solve for x. All right, so how do we solve given this? All right, it's quadratic, and so we need to move these two pieces over here and set it equal to 0. So minus x, minus 1, minus 1. So x squared minus 11x plus 24 is equal to 0. So we've got our quadratic, and we can, do quadratic formula or factoring. Generally, these are pretty easy to factor. Something that multiplies to 24 adds up to 11. 8 times 3 is 24. 8 plus 3 is 11. All right, so it needs to be both negative, so that way when they multiply, two negatives make a positive, and when they add up to a negative. Set them each equal to 0. We get x is equal to 8, x is equal to 3, and we want to go through and check. So our first check, let's check the 8, because it's our first one here. So we're going to start all the way at the beginning. So 8 is equal to 8 plus 1, 8 plus 1 to the 1/2 plus 5. All right, what's 8 plus 1 is 9. So if I want to just go ahead and write this, 8 is equal to the square root of 9 plus 5. Well, what's the square root of 9? It's 3. So 8 is equal to 3 plus 5. That works. That's perfect. So here you go. That one is great. All right, 3 is equal to 3 plus 1 to the 1/2 plus 5. So 3 is equal to, well, 3 plus 1 is 4. The square root of 4 plus 5. What's the square root of 4? It's 2. 2 plus 5 is 7. So 3 does not equal 7. Okay, so this one is here. I'm going to label as our extraneous solution. All right, so 8 works, 3 does not. All right, 2 minus the square root of x plus 1 equals negative 5. All right, bunch of different ways to start this. We want to get the radical by itself. So we can either minus 2 and then divide it or multiply everything by a negative. Or what I'm going to do is I'm actually just going to move this radical over here. I'm going to say plus the square root of x plus 1 plus the square root of x plus 1. Right, so that cancels here. And how am I going to get rid of this minus 5? I'm going to do plus 5. So 2 plus 5 is 7. And those cancel there, those cancel out, and we've got the square root of x plus 1. You can do it the longer way if you like, or the other way. I guess it's necessarily longer, and then we've isolated the radical, so we want to go through and square everything. Squared, squared. So 49 is equal to x plus 1. Minus 1, minus 1. X is equal to 48. I keep doing it prematurely. So 48, we plug that in. 48 plus 1 is 49. The square root of 49 is 7. 2 minus 7. Does 2 minus 7 equal negative 5? Yes, it does. All right, this one is already, the radical's already isolated, so our first step is just to square. So x plus 4 is equal to x squared minus 16x plus 64. All right, if you want to know how we get here, go back and take x minus 8 and square it. X minus 8 times x minus 8 gets you here. We want to take here and move, do minus x minus 4, minus x minus 4, 0. Is equal to x squared minus 17x plus 60. All right, and again, you might do quadratic formula, or if you know things that multiply to 60, 1 and 60, 2 and 30, 3 and 15. No, that's not right. 4 and 15. 3 and 20. 5 and 12. And that's our winner, 5 and 12. Because 5 times 12 is 60, 5 plus 12 is 17. So 0 is equal to and then they both need to be negative, so they add up to that, and they both need to be negative so that when they multiply, they make a positive. So x is equal to 12, and x is equal to 5. And we go through to check that. The square root of 12 plus 4 equals 12 minus 8. Well, 12 plus 4 is 16. Square root of 16 is 4. 12 minus 8 is 4. So that one works. We go to do the other one. Square root of 5 minus 4, or plus 4, is equal to 5 minus 8. Well, 5 plus 4 is 9. Square root of 9 is 3. 5 minus 8 is negative 3. So that one is extraneous. All right, are either of these ever both going to work? Unfortunately, they're not going to both ever work. All right, remember our parent function starts off at 0, 0 and rises up. So how many times does the square root function cross the x-axis? It only crosses once, so we can only have one solution. All right, quadratics cross twice, so you can have two solutions, or they possibly can cross once. You can have one solution, or they can cross no times. All right, so you've got 2, 1, and 0. All right, this one, you can have 1. If it moves down, you can start here, and it can go up. You've got one solution, or if it gets moved up, you could start here, and it has 0. So it could have no solutions, but it also could only at a maximum have 1.